I would like you to take your blank periodic table, and we're going to identify the key elements for all 4 trends that you did in your lab. So I'm going to sketch out a very rough periodic table here. Very rough. I think it's going to drive me crazy to have this line be so slanted.
Straighten it out thing.
That doesn't work on this, Connor. So thank you for your thoughts. This is just freehand drawing, and so I can't straighten it. It's not like I drew lines.
One line at a time.
Okay, anyway, we're going to move on. And let's talk about who's the fattest atom on this periodic table. This fat atom is also the most reactive of all the metals. What was that, Josh? Fat francium. So we're going to circle that corner, and we're going to put FR for francium. And I'm trying to give you ways of remembering these things. So as I go this way and as I go this way, it's increasing atomic mass.
We're supposed to go through 1, 2, 3, 4, 5 rows down, right? Do we have to write that?
I did write it down.
You want to draw this on your blank periodic table to help you remember these periodic trends. My lanthanide actinide series is down here. So we're ignoring them. And this is increasing atomic mass. Francium is the largest radius. Mass, not mass, my bad. Radius. Yeah. Just because francium is the fattest doesn't mean francium is the heaviest. As it turns out, he is not the most massive, if I were to personify it, the most massive element. Connor, I don't know if you're 118, but this is radius. So francium increasing atomic radius. So if you just remember that's the biggest atom, you could tell me, hey, if I compare carbon and nitrogen, who's bigger? As you go this way toward francium, you're getting bigger. So carbon is bigger than nitrogen. Now, why that happens is actually a really cool concept. As you move across the periodic table this way, what's happening is that you are getting more electrons and more protons in the same energy level, in the same shell. So what do electrons and protons do with each other? They're attracted to each other. So they're pulling tighter and tighter, and you're increasing that electrostatic force and that electrostatic attraction between the nucleus and the electrons. And then if I go down and I jump down here, I've actually jumped out of shell. So as I move down, I am going out energy levels, so the radius is getting bigger, and that makes sense, right? But Haley, as you go across the periodic table, you're adding electrons and protons in the same shell. So the shell actually tightens up a little bit. It's like it's working out more. Okay, that's atomic radius. What about mass? What is the most massive element? If you look in your textbook, I think it's called UUO. Yeah, it's UUO. All right. So mass increases as you go down, but mass increases as you go this way. So atomic mass. And maybe I'll put a couple arrows here. Mass. UUO.
UUO.
Synthetic, it only exists for brief seconds before it then immediately starts decaying. But hey, we've seen it, we've created it ever so briefly. Atomic mass increases as you go across. So which one has more mass, carbon or nitrogen? Nitrogen. Okay. Next. Have a seat. Increasing atomic radius, increasing atomic, so radius, my arrows go the other way, don't they? The radius is bigger that way, toward francium. Fat francium, heavy UUO. And what was one of the other trends? You had two other trends. Do you remember them? Anyone remember them? Electronegativity and ionization energy. Let's talk about ionization energy. That's the energy it takes to make an ion or remove an electron. Who is perfect and does not want to lose electrons? Noble gases. Who has the best electrostatic connection between their protons and electrons? Helium. So we're going to draw a circle here around helium. Helium, that little buggy right there, helium has the greatest ionization energy. Greatest ionization energy. That means it's really hard to make an ion out of helium. And you have to pour a lot of energy into the reaction to pull that electron off. The most energy out of any other element on the periodic table. Helium holds onto its electrons stronger than anybody. Kind of like a mom with only 2 kids instead of down here francium's like a mom with 100 kids. It's really hard to, it's pretty easy to pull an electron off of francium because she's got shell after shell. She has 7 shells, and way out there on the end of that 7th shell, there's a kid hanging out there. She's not going to notice if she loses it. If I were to personify this. So the trend is greatest ionization energy is that way, and it's that way. What about the last one, electronegativity? Who is the most electronegative? Does anybody remember that from your lab? The most electronegative. Maybe we should do this in blue. Who is the most reactive non-metal? Fluorine. Right here. I'm going to redraw that line. Sorry. Fluorine is the most electronegative. So if you remember these corners, electronegativity, what is that? That is the ability to attract electrons when you're in a bond. So fluorine is always taking people's electrons. So increase in electronegativity as you go this way, and increase in electronegativity as you go up. Those are your 4 major trends. So if you can remember, francium is fat, fluorine is a thief, helium is perfect and hates to be disturbed, and UUO is massive. Then you know your trends, because as you head toward those corners, trends are increasing. That's it for today, folks.